Ronan. I'm an Android engineer and a Scrum Master here at Distill SEH. I'm going to talk to you today briefly, I'll try and keep it brief, about Kotlin versus Java in Android development. The talk is going to be loosely tied back to Android development, so you don't need to necessarily have any previous Android experience, or Kotlin or Java experience might be a bit helpful, but we'll see how it goes anyway. If anyone has any questions, feel free to give me a shout afterwards. So I'll start off with Java. I'm sure most people have some idea what it is. It's an object-oriented language. It's created by Sun Microsystems in 1995, and it's a WARA, or a write once, run anywhere language, ideally anyway. That's all I'm going to say about Java, because it's fairly well known. What I am going to talk about is Kotlin. So Kotlin is an open source statically typed language that runs on top of the JVM. It's fully interoperable with Java, created in 2011 by JetBrains, who are the creators of IntelliJ, which is quite a popular IDE for Java. And they're also the creators of Android Studio as well, which is quite good. So created in 2011, and then the first release was actually in 2016 as the first stable release. It's fully cross-platform, so you can run it on Mac, PC, web, Android, or even iOS to a limited degree. So it's quite well widely used. It's fully interoperable with Java, as I said, so you can actually switch back and forth between Java and Kotlin. You can have a Java file talking to a Kotlin file and vice versa. The reason it was created was because the guys at JetBrains, they wanted to write with a language that had some features that most of their languages didn't. So they tried using Scala for a while, but it wasn't quite up to scratch. So they decided to just go ahead and make their own. And the name Kotlin comes from an island in Russia. They wanted to kind of mimic the Java naming of the Java in Indonesia. So they went for their local island in Russia. I don't know anything about it, but I know that there was a massive oil spill there a couple of years ago. So that doesn't reflect the language at all. So Kotlin Android adoption. So Google officially supported Kotlin with Android Studio 3, which came out in October of 2017. And since that date, they've transitioned all their developer guides from purely being written in Java to Java and Kotlin. And now in some cases, their developer guides are only written in Kotlin. So they're really strongly pushing it. And it's almost daily growing much bigger. There's a massive uptake in the Android community. You'll see that there's a lot of apps that are going up to the Play Store now that are actually only written in Kotlin and are no longer written in Java. So it's becoming a really popular thing. So why adopt Kotlin? Brevity, it's really, really easy to use. It's really quick to use. The key selling point that most people take from it is that it reduces most of the boilerplate code. I'll show you some examples of that later on. But you can do the same thing. In Kotlin, it might take you 1 line, Java might take you 5-6 lines. It's created and maintained by IDE makers, as I said, JetBrains, and they're constantly monitoring it and releasing updates for it. Backed by Google, huge community. In terms of Android development, there's a relatively small overhead. So if you were to include Kotlin in your Android app, it would actually only increase the app by 964, give or take, kilobytes. And that's as of one of the latest releases as well. Performance benefits, which I'll go into a little bit later on as well. It's much faster, much more performant than Java, in most cases anyway. It's relatively easy to learn. If you know Java, it's quite easy to pick it up. If you're an iOS developer, it's very similar to Swift. A lot of the syntax and stuff is the same. And it's much easier to avoid the $1 billion mistake, which if anyone doesn't know what that is, it's null pointer errors. With Kotlin, it's quite easy to avoid them. It's almost kind of, if you do have a null pointer, then you're doing something very wrong and you probably don't understand too much what's going on. So the main part of this talk is just going to be some code comparisons between Java and Kotlin. The first one here is null safety, the $1 billion mistake. So you can see over on the left-hand side here, it's a simple to-do list. You check and see if your beer is not null. If it's not, you're going to brew it and you're going to drink it. Standard Java. And the method functions and stuff down here are the same. In Kotlin, we have what's called a safe call operator. So you no longer need to specifically check if something is not null. you call this save call operator, and if you pull let after it, then basically what you're saying is anything within these brackets here is going to assume that the beer has not been null. The beer object is not null. If it is null, it'll never hit here. So it's quite an easy way to use it. You can also see that you no longer need to call beer. You can just reference it with the it, which is quite nice as well. You also can notice here that in Kotlin, we no longer need to call it void. It's called fun. Every object is called, or every method is called fun. By default, functions or funs are public, so you don't need to specify public, they just are. You need to specify if they're private methods though. You can also see how parameters are passed to objects are quite different. So Java, beer, again, you know, Java, it's fairly standard. Kotlin, it reverses around. So that is something that kind of catches people when they initially start with Kotlin, because it's a complete reversal. And down on this recycle bottle, sorry about the terrible name, and I could not think of a proper structure to call my objects and stuff for this, so I just I went with the theme of the night, which is beer. So so in here we have this beer object as a question mark after it, and what that means is that that object might be null. So if there's no question mark, then you're forcing to say that this object will never be null. Question mark, it can be null. In the method here, the two are the not null assertion operator. You're basically saying to the system that this object is not null and do whatever you want. If you were to call this on something that could potentially be null, that's where you get your null pointer mistake. Variables then. So on the left-hand side here, we have the standard ways of creating variables in Java. We have an uninitialized variable, an initialized variable, a final, a null, and an int. On the right-hand side, we have a latent int. So a latent int var is actually the exact same as an uninitialized object. You're stating to the compiler that you're going to initialize this variable somewhere else in the code block. We have var and val, so basically a mutable and immutable object. If you have something that's never going to change, obviously put it as immutable, or opposite for mutable. Here is the nullable object, as I talked about earlier on, and we have an int here as well. So the difference between Java and Kotlin is in Kotlin, there is no such thing as a primitive. Primitives are objects. So in Kotlin, you could potentially have an int that is null, which doesn't happen if you're using primitives in Java. Casting and extensions. It's kind of hard to fit this on the slide, to be honest. So Java, you're casting this craft beer to be an instance of pale ale, using a ternary operator. If it is, it's craft beer. If not, it's null. In Kotlin, we don't need to use this long-winded instance of blah, blah, blah. We can just use as with a question mark. So what that's stating is craft beer as a pale ale. If it's not, then because we have a question mark, it's going to be null. And then for the extensions, over here, Java's verbose. You have to specifically say that you're going to extend beer and that you're going to implement the beer interface. And in Kotlin, the syntax kind of goes away and it's much easier to read and it flows a lot better. Again, that kind of catches people out the first time they start playing around with Kotlin because they're a bit unsure as to how things fold together. Standard for loop on array events. And these are really basic examples, but I just kind of wanted to get the syntactical differences across. So as I said earlier on, Java, you have ints. Kotlin, you don't, which means in a standard for loop in Kotlin, you don't actually necessarily need to do it. You have to use standard fors in Java because you can't use a for each on an int, on a primitive, but you can, and you don't have the primitive in Kotlin, so you don't have that issue. Other than that, syntax is fairly similar. Obviously, you have lambdas, which is only a relatively new thing for Android Java heads anyway, so it's quite nice to have this out of the box. Here's an example if you did want to use a standard for loop, but you don't have to. So going back to this loop, I wanted to kind of show the kind of performance benefits from moving to Kotlin over Java. So this is just a loop that has an array of a million ints, and we're going to go along and we're just going to count to 3000 and pop it array. Doing that in Kotlin on the first pass, so with benchmarking, you generally do a number of passes and then you take the average and that's your benchmark figure. In Kotlin, it took 42 milliseconds on the first pass and it took 4,843 milliseconds in Java on the first pass. And that's a 115, give or take, % increase in speed for Kotlin. And then on the second pass, it actually only took 2 milliseconds in Kotlin and 1,700 milliseconds in Java, which is almost a 1,000% increase. Again, it's a very simple example. You're probably not going to be doing that too often, but that's just an example of how powerful Kotlin can be. For eaches, we have a little bit different syntax here. It's not massively different, but I just kind of wanted to show the difference between Java, you can have array lists, Kotlin, you can have mutable lists. Not necessarily the same thing. As it stands in Kotlin, they are. A mutable list is an array list, but that may change down the line. But the way you create a list is kind of slightly nicer in Kotlin. It's a little bit quicker. To my eyes, a little bit easier to read and a little bit less verbose. Mapping then. So in Java, if you wanted to add objects from one array to another array, you need to loop over them and add them back. In Kotlin, you can just call it .map. You pass in the list you want to map from, and you have the option of making it mutable to a list, whatever you want to do. Then we have a flat map as well. So if you wanted to, for whatever bizarre reason, you wanted to loop over a list of arrays, extract each string and extract each character and put each character into a list. That's how you do it in Java. It's quite verbose and it's a little bit tricky, easy to mess up. Kotlin, it's literally one line to do that. And that's really powerful if you want to cut down your code size and whatever. Strings are a little bit easier. Obviously, you'd use string builders in Java, but this is just a basic example again. So in Java, you need to concatenate your strings. Kotlin, you do the same, only you can actually pass in the parameter in a very JavaScript-y, I think, way, which is kind of nice as well. So this is a little bit more Android-y. Finally got to something about Android. On the left-hand side, we have what's called a text view, which is just a standard view in Android where you show some text. And if you want to access that view in Android, you need to call view, which would be your screen, find the view, label text view. And I can guarantee you that that haunts Android developers' dreams because they've been doing it for years and it's painful. You see find view by ID coming at you in your sleep. So you can assign that then to a text view and then you just set your text on it. In Kotlin, you can actually look up the view layout. So all layouts are written in XML. You can actually look up the layout ID, which in this case is label text view. It converts that to a variable in your class in the background, and you can actually just reference it straight away, and it makes life so much easier. Again, here we have a click listener. A click listener is what it is. If a user clicks on something on your phone, then we need to listen out for that. Quite verbose in Java here, as you can see. In Kotlin, again, it's a one-liner, it's much easier. There are alternatives for Java when it comes to this kind of stuff. There's libraries called Butterknife, where they like inject the views in with dependency injection. That make it a little bit nicer to use, but Kotlin just kind of takes the biscuit there. Singletons, so a safe singleton in Java is what you see on the left here. For it to be a truly safe singleton, you need to have that or almost exactly that. Some of the Java heads here can probably tell me if there's any mistakes there. Kotlin supports a method in the box, so you just call object singleton and you have it. So that's quite powerful, I think. As I said before, it's fully compatible with Java. So in our Java class, we're calling instances of the Kotlin beer object. And then in Kotlin, we're calling instances of our Java beer object. Again, you can see I was struggling for naming conventions here. In Kotlin, we have what's called a data class. A data class is used where the main purpose of the object or the class is to just hold data. So there's no extra functions in there. You literally just have an object and you have a hash code and you have your toString and your equals. In Kotlin, we don't need to specify or override those toStrings or equals. They're kind of done in the background if we specify its data class. We can also specify whether objects are nullable or whatever in here as well. And that's it. Any questions?
And what do you call this? Swap to